Welcome to this presentation on the MVC or Model View Controller design pattern for web applications. Today we'll explore how the Model View Controller architecture helps developers build web apps that are organized, scalable, and easier to maintain. I'll begin with a quick overview of what web applications are for those less familiar. Then I'll show how the MVC design pattern improves both code structure and collaboration. To start, what is web application? Well, it's more than a website. It's an interactive system that runs in a browser and communicates with a server. When a user interacts with the application, the browser sends an HTTP or Hypertext Transfer Protocol request to a server, which processes them, accesses a database if needed, and sends data back to the browser for the user to see. An example could be Gmail or Spotify Web. Understanding this client-server flow sets the stage for why architecture patterns like MVC are so valuable. For example, a little more in depth is if you would like to send an email through Gmail, you must first write your email, give it a subject line, and input who you would like to send this email to. Once you click send, the client makes an HTTP request to the server to send that email to the specified recipients. Once the server-side logic executes, it will then send an HTTP response back to the client. This response will update the client to let the user know that the email was either sent successfully or if there was an error sending that email. So why do we need this structure? Well, as web applications grow in size and functionality, their code can quickly become tangled. Without structure, changing one part of the interface might unintentionally break another. The MVC pattern helps address this by dividing responsibilities among layers. This approach supports modular design, a fundamental concept in software engineering that promotes easier maintenance and teamwork. For example, changing the database associated with an application will not necessarily require any changes to what the user sees in their browser on the client side of the application. Now to introduce the Model View Controller pattern. This pattern divides an application into three components: the model, the view, and the controller. The model manages data and associated logic. The view handles the visual interface the user sees, and the controller links them by processing user input and updating both layers. This separation allows different developers to work on different parts of the system without interfering with each other, therefore allowing more collaboration. So now let's get into how the Model View Controller actually works. Imagine a user submitting a login form. The view collects the user's credentials and sends them to the controller, likely after pressing a login button. Now this could be an email and password that the user inputs into their respective fields. The controller checks the credentials with an HTTP request by asking the model, or a server, to validate them against stored data. Once the model responds by sending an HTTP response, the controller updates the view, either showing an error message or logging the user in. This is just one quick example flow of how these different components interact with each other to allow the user to complete actions by interacting with the browser. So now take a second to pause and think. Look at these examples and think about where each one fits in the MVC pattern. Take about 10 seconds to think about what part of the MVC these different components would fit under, either the model, the view, or the controller. Alright, so here's the answer to the previous question. A button or a search bar is a part of the view. It's what the user interacts with and sees in their browser. The HTTP request and password validation logic belong to the controller, which handles user actions and application flow. Think about it as something that might happen after a button is pressed in the browser. For example, password validation after the user enters their email, password, and then clicks the login button. And finally, the database table represents the model. It's where the data lives and business rules apply. The model can be thought of as representing real-world data, similar to classes in object-oriented program. These examples are just a few ways that MVC is applied to everyday components in real web applications. Now here is a very simple example of what a model might look like in JavaScript code. Here you can see an array called to-dos that will represent a to-do list made of to-do items. The function addToDo takes a task and adds it to the array, while the getToDos function returns the array of to-dos. As you can see, we have a variable, to-dos, that holds the relevant data that we would like for the user to see and some basic ways to interact with that data. Here you have the HTML and JavaScript code for what the user actually sees. The HTML code has a to-do list element, which is the UL element in HTML, an input element that allows the user to type in a new to-do list item, and a button the user can click that says add. In the JavaScript code here, what happens is that when render to-dos is called, it populates the list created in the HTML code with whatever is held in the to-dos array that exists in the model. Now this looks like functional code that can update items in our model. However, without the controller, none of these elements are actually able to function correctly. The controller is what really brings these two components together to make a fully functional system. What this JavaScript code does is add an event listener to the add button created in HTML code in the view. This listener now allows a new to-do to be added to our to-dos array created in the model with whatever exists in the input element in our view. So now, if you put it all together, the user is able to see the list of to-dos, enter a new to-do in the input element, and click on an add button, which all exist in the view. When the add button is clicked, it takes information from the view and sends it to the model. The corresponding information, a newly created to-do in the to-do list, is now displayed for the user to see in the view. The MVC pattern appears in many different web frameworks. Python Django structures code into models, views, and templates. Ruby on Rails uses MVC conventions for quick development. ASP.NET MVC is common in many enterprise environments, and in modern JavaScript stacks, React handles the view layer while Express or Node act as the controller and model layers, showing MVC's flexibility across different ecosystems. There isn't one right or single way to use MVC when creating a web application, so it's up to you to pick the right framework to get the job done. MVC brings structure, maintainability, and scalability. And these are just a few of the benefits you get by using this design pattern. It enables different teams to work simultaneously on different layers, encourages reusable code, and isolates bugs more easily. This division makes the code base cleaner and supports better long-term project sustainability, which is one of the main goals of software engineering. Now, MVC isn't perfect. While it has its clear benefits, there are always going to be critiques. For small projects, it can feel like unnecessary overhead. Beginners may also find the pattern somewhat confusing at first. Additionally, in some frameworks, developers struggle to maintain balance between layers, which creates overly complex models or controllers. Recognizing these trade-offs helps in applying MVC appropriately and in an efficient way. Now, MVC has also inspired many later architectures, including MVP, the Model View Presenter, and MVVM, the Model View View Model architectures. Modern front-end frameworks like React or Angular borrow these ideas while introducing their own component-based designs, which tend to be even more reusable. So even as technology evolves, the core principles of MVC, separation of concerns, and modularity, remain central to software engineering. To conclude, the MVC pattern offers a clear and proven structure for web applications. It simplifies maintenance, encourages teamwork, and forms the conceptual foundation for many modern frameworks. Even as software design trends evolve, the lessons of MVC continue to guide how we build robust and scalable web applications today.